When different elements combine, a chemical reaction takes place and a new product is formed. If we take calcium, which is a solid, plus carbon, which is a solid, and react it in oxygen, which is a gas, a chemical reaction takes place and a new product is formed. The name of that product is calcium carbonate. The T in 8 or 8 stands for triple, meaning that the compound contains 3 different types of elements. We have oxygen, which is known as the silent element. If a compound ends in 8 or 8, oxygen is always present. Now, because the compound contains 3 different elements, we have to use a different page in our data booklet. If a compound ends in 8, we use page 8 of the data booklet. What we have here is a table of selected ions. What we can see is that these ions contain more than one type of element. These are known as group ions. If a compound ends in 8 or 8, we do need to use page 8 of our data booklet. We have to be able to write the chemical and the ionic formula for compounds which contain these group ions, and we have to make sure that we've got it in the correct format. Chemical formula only show the chemical symbol and how many you have of each, whereas the ionic show the chemical symbol, how many you have, but also show the charge or the valence of that particular group ion. So I'm going to start from left to right going across this table. In the first column, we can see that there is only one group ion present, which is known as the ammonium ion. It is the only positive ion found in the chemistry data booklet. The chemical formula would be NH4. We need to remember to keep a bracket around it. The ionic formula, however, would be NH4+. We need to make sure that the charge is placed at the top right-hand side of the chemical symbols. If we were to look at the second column and focus on the permanganate ion, the chemical formula for the permanganate would be MnO4 with brackets around it, and the ionic would be MnO4-. Now in this column there's a wee tricky one, and it's the only one that ends in "ide". We would assume that if it ended in "ide", it would only contain 2 elements, and we would only be using page 6 of the data booklet. We have to be careful with this. This is usually an A mark question. So if we look at the hydroxide ion, the chemical formula for that would be OH and kept in brackets. And the ionic is OH-, and remember to put the brackets around it. It's got a valence of 1, which can be found at the top of that column. The carbonate ion, we would have the chemical symbol for that as CO3, kept in brackets. And if we were writing the ionic formula, we would write CO3 2- and keep it in brackets. The last column, we have got the phosphate ion. If we were writing the chemical formula, we would write PO4 in brackets, and the ionic, we would write PO4 3-. The valence of that ion is 3. I'm going to go through a couple of worked examples showing you how to write the chemical and ionic formula for compounds which contain group ions. So you are required to use page 8 of your data booklet. This first example is going to get you to write the chemical and ionic formula for sodium nitrate. So we start off with our SVSDF. The symbol for sodium is Na. It's found in group 1, valency 1. Nitrate ends in 8, so we're going to use page 8 of our data booklet. The symbols are NO3, and we need to remember to keep a bracket around that. It's got a valence of 1. Swap the valencies over. What number can both be divided by to keep it a whole number? That's 1. 1 divided by 1 is 1, and 1 divided by 1 is 1. We write down the symbol for sodium, which is Na, How many of those have we got? We've got 1. But we don't write ones in science, so we don't write any number directly after the symbol. Symbol for nitrate, bracket, NO3, close bracket. How many of those have we got? We've got 1. And again, we don't write the number directly after the chemical symbol. Because we've only got 1 nitrate, at this stage we can remove the brackets. Now we're going to write the ionic formula for sodium nitrate. The symbol is still the same, Na, valency 1. Nitrate, NO3, valency 1. Remember, metals always lose electrons to form positive ions, so the positive charge will go above the sodium and the negative charge will go above the nitrate. We need to make a sandwich and wrap it up. 1 times plus is plus, so the charge on the sodium is 1 positive, and we need to keep that in brackets. The charge on the nitrate is 1 negative, so we write a negative and keep it in brackets. Swap the valencies over. Highest number that can be divided by is 1. And we copy down exactly the way that we've written the symbol at stage 1. We've got bracket, Na positive, close bracket, bracket, NO3 minus, close bracket. Remember, because we've only got 1 of each type of ion, at this stage, and only for this example here, when we've got no number directly after the bracket, we can get rid of those there. This second example wants us to write the chemical and ionic formula for magnesium carbonate. We start off with our SVSDF, symbol for magnesium, Mg, found in group 2, valency 2. Carbonate ends in 8, so we use page 8. The symbols are CO3, and we need to remember to keep a bracket around that. Valence of 2. Swap the valencies over. Highest number both can be divided by is 2. So 2 divided by 2 is 1, and 2 divided by 2 is 1. The chemical formula is Mg, bracket, CO3, close bracket. Because we've only got 1 of our carbonate, we can remove the brackets. Same steps on the right hand side for the ionic formula. Remember, the only stage that's different here is that we have to make a sandwich and wrap it up. The valency for magnesium is 2 and the charge is positive. That gives us a 2 positive ion, which we must keep in a bracket. The valency of the carbonate is 2 and the charge is negative, which means it's a 2 negative ion, and we must keep it in a bracket. We swap the valencies over. Highest number they both can be divided by is 2, which means the ionic formula is bracket Mg2 plus, close bracket, bracket CO3 2 minus, close bracket. Again, because we've only got 1 of each type of ion, we can get rid of the brackets. Our double check is to make sure that we have the same number of positive and negative charges, which we do. This last example wants us to write the chemical and ionic formula for ammonium phosphate. Now this would be classed as an A-mark question, and that is because both parts of the compound are found in page 8. Both are made up of group ions. So we start off with our SVSDF. The symbol for ammonium can be found on page 8, and that is NH4, and we need to keep a bracket around that. It's got a valence of 1. Phosphate has the symbols PO4, and again we need to keep that in a bracket. It's got a valence of 3. We swap the valencies over. Highest number both can be divided by is 1. So therefore this time the chemical formula is bracket NH4, close bracket. How many of those have we got? We've got 3, so we pop a 3 outside of the bracket. Phosphate is bracket PO4, close bracket. And because we've only got 1 of those, we can get rid of the bracket. Again, it's only the one step that's slightly different in this formula. We need to make a sandwich and wrap it up. The charge inside the ammonium is going to be positive. So we should have bracket NH4 plus, close bracket. And for the phosphate, we should have bracket PO4 3 minus, close bracket. Swap the valencies over. Highest number they can both be divided by is 1, which means our ionic formula this time is bracket NH4 positive, close bracket, with a little 3 outside of the bracket. Bracket PO4 3 minus, close bracket. Again, we would get a correct answer for leaving all of the brackets there, but it's more common for us to remove them if we only have one type of ion, and therefore we can remove the brackets around the phosphate. Our double check here is to make sure that our charges balance. We've got a 1 positive inside the bracket, multiplied by the 3 outside the bracket, gives us a total charge of 3 positive, and the phosphate ion has a charge of 3 negative. They balance. So here are 8 examples of compounds which end in ate or ite. There's a little tricky one in there that ends in ide, but you're still going to have to use page 8 of your data booklet to write the chemical and ionic formula for that example. If you want to pause the video, you can have a go, and when you're ready, you can resume the video and the answers will pop up on the screen. So the first 3 past paper questions that we're going to go through are going to be asking you to write the chemical formula, and the last 3 are going to be getting you to write the ionic formula for different compounds. This past paper question is from the Intermediate 2 2010 multiple choice question 7. The question asks, the formula for magnesium sulfite is... So we start off with our SVSDF. The symbol for magnesium is Mg. It's found in group 2, valency 2. Sulfite ends in ite, so we're going to use page 8 of our data booklet. The symbol is SO3, and we need to remember to keep a bracket around that. It's got a valence of 2. Swap the valencies over. Highest number both can be divided by is 2. 2 divided by 2 is 1, and 2 divided by 2 is 1. So the chemical formula is Mg, bracket, SO3, close bracket. But because we don't have a number directly after the sulfite ion, we can remove the brackets. This next past paper question is from the Intermediate 2 2009 multiple choice question 8. The question asks, what is the correct formula for aluminium sulfate? It's only asking for the formula, so we're going to be working out the chemical formula. We start off with our SVSDF. Symbol for aluminium is Al. It's found in group 3, valency 3. Sulfate ends in ate, so we use page 8 of the data booklet. The symbols are SO4, but we need to remember to keep a bracket around that. Valency 2. Swap the valencies over. Highest number both can be divided by is 1. So the chemical formula is Al2 bracket SO4 close bracket 3. This question's from the Intermediate 2 2008 past paper written 15A. The question asks, write the formula for potassium permanganate. The compound ends in 8, so we're going to have to use page 8 of our data booklet. We start off with the SVSDF. Symbol for potassium is K, found in group 1, valency 1. Permanganate, use page 8. The symbol is MnO4, and we need to remember to keep a bracket around that. It's got a valence of 1. Swap the valencies over. Highest number both can be divided by is 1, which means the chemical formula is K bracket MnO4 close bracket. Because there's only 1 permanganate, we can get rid of the brackets. This question's from the National 5 2019 past paper, written 11A. Write the formula showing the charge on each ion for calcium carbonate. So we're looking at ionic formula for this particular question. And the compound is calcium carbonate, which means it ends in 8, and we're going to have to use page 8. The symbol for calcium is Ca. It's found in group 2, valency 2. The carbonate is CO3, the valency 2. Metals always lose electrons to form positive ions, so the calcium will be a positive charge, which means that the carbonate must be the negative charge. Remember, for ionic formula, we make a sandwich and wrap it up. The charge on the calcium ion is 2 positive, in brackets, and the charge on the carbonate ion is 2 negative. Remember to keep it in brackets. Swap the valencies over. What's the highest number they can both be divided by? That's 2, which means that the formula for calcium carbonate is Ca2 plus CO3 2 minus. This question's from the National 5 2014 past paper, written 3D. This is based on a close reading aspect, which means that you're going to have to be able to pick out information from the text and answer the questions which follow. This question specifically asks us to write the ionic formula for saltpeter. When we identify the word saltpeter in the text, we can see directly after that we have the name of the compound, which is potassium nitrate. So we want to work out the ionic formula for that compound. We have to do our SVSDF. The symbol for potassium is K. It's found in group 1, valency 1. Nitrate, we use page 8. Symbol NO3, valency 1. Remember, it's ionic, so we have to show the charges. The potassium will have a positive charge. Remember to keep the ion in brackets, because we make a sandwich and wrap it up. The nitrate will have a negative charge, and we need to put that in brackets too. Swap over the valencies. The highest number they can both be divided by is 1, which means that the ionic formula for potassium nitrate is K positive NO3 negative. Remember, the charges cancel each other out. This question is from the National 5 2013 specimen, written 3A. The question asks us to write the formula showing the charge on each ion for the aluminium hydroxide. Now, we want to work out the ionic formula, which means we have to show the charges. But this one's the tricky one, because straight away, by looking at it, if it ended in "ide", you would assume that it had 2 elements. Remember, hydroxide is the tricky one. That's found on page 8. The symbol for aluminium is Al, valency 3. The hydroxide ion is OH, with a valency of 1. Metals always form positive ions, so therefore the charge on the aluminium will be 3 positive. We must keep that in a bracket. The charge on the hydroxide will be negative, and we must keep that in a bracket. Swap the valencies over. Highest number they can both be divided by is 1. So the molecular formula we have is Al3 plus, bracket, OH minus, close bracket, 3.